Good morning, everyone. Thank you for listening our presentation today. I will present a review paper about recent advances in alcohol biorefineries for biofuel production. This paper discusses how alcohol biomass can be converted into renewable fuel through the optimized polysaccharide utilization. It also highlights how AI and life cycle assessment can improve both the efficiency and the sustainability of the biofuel production system. Before going through our presentation, I would like to show you all a short video about how biofuel works.
Biofuel production involves converting organic materials, such as plants, agricultural residues, algae, and waste products, into fuels that can be used as alternatives to traditional fossil fuels like gasoline and diesel. Here's a simplified overview of how biofuel production works. Feedstock selection. The first step in biofuel production is selecting suitable feedstock, which are the raw materials used to produce biofuels. Common feedstocks include crops like corn, sugarcane, soybeans, and oil palm, as well as non-food sources like algae, agricultural residues, such as corn stover and wheat straw, and waste materials, such as used cooking oil and animal fats. Biomass conversion. Once the feedstock is collected, it undergoes a conversion process to extract or convert the organic matter into biofuels. There are several conversion technologies used in biofuel production. Fermentation. This process involves breaking down sugars or starches in feedstock crops into ethanol through fermentation by microorganisms such as yeast. This is commonly used for producing ethanol biofuel, which can be blended with gasoline. Transesterification. This process converts vegetable oils, animal fats, or recycled cooking oils into biodiesel by reacting them with alcohol, usually methanol or ethanol, and a catalyst. Biodiesel can be used as a direct replacement or blend with diesel fuel. Thermochemical conversion. Thermochemical processes such as pyrolysis, gasification, and hydrothermal liquefaction convert biomass into biofuels through high temperature and pressure conditions. These processes produce biofuels such as bio-oil, syngas, and biochar. Refinement and purification. The biofuel produced undergoes refinement and purification processes to remove impurities, water, and other contaminants. This may involve distillation, filtration, and other separation techniques to obtain high-quality biofuels suitable for use in engines. Blending and distribution. Once refined, biofuels can be blended with traditional fossil fuels to produce blends like E10, 10% ethanol, 90% gasoline, or B20, 20% biodiesel, 80% diesel. These blends can be used in conventional vehicles with little to no modification. Biofuels are distributed through existing fuel distribution channels and infrastructure, such as gas stations and fuel terminals. Utilization. Biofuels can be used as direct replacements or blends with gasoline and diesel fuel in vehicles, trucks, buses, ships, and airplanes. They are considered renewable and sustainable alternatives to fossil fuels, as they can help reduce greenhouse gas emissions and dependence on imported petroleum. Overall, biofuel production involves a series of steps, including feedstock selection, biomass conversion, refinement, blending, and distribution, to produce renewable and sustainable fuels from organic materials. Biofuels play a crucial role in transitioning to a more environmentally friendly and sustainable energy future.
Global energy demand is continuously increasing due to population growth and industrial development. Currently, most of our energy still comes from fossil fuel, such as coal, oil, or natural gas. These energy sources are a major contributor to greenhouse gas emission and climate change. Because of these environmental concerns, researchers are increasingly exploring renewable and sustainable energy alternatives, including biofuel produced from biomass. So why this research is important? Another important issue today is the rapid increase in global waste production. A large proportion of this waste consists of organic biomass, such as agricultural residue and food waste. However, only a small percentage of these biomass is effectively treated or reused. Biorefineries offer a promising solution because they have converted biomass waste into biofuel and other valuable bioproducts. This review paper focused on several key topics related to alcohol biorefineries. First, it summarized recent advances in alcohol biorefinery technologies. Second, it discussed strategy for optimizing the utilization of polysaccharides present in alcohol biomass. Third, the paper highlights the role of the AI and machine learning in improving biofuel production processes. Finally, the author evaluates sustainability using life cycle assessment. So what is biorefinery? A biorefinery can be compared to the petroleum refinery, but instead of using fossil resources, it used biomass as the raw material. Through different biological and chemical processes, biomass can be converted into multiple products such as biofuel, chemicals, materials, and energy. There are several types of biorefineries, including conventional biomass refineries, lignocellulosic biorefineries, and marine or algal biorefineries. Why algal biorefineries? Algal are considered one of the most promising feedstock for biofuel production. They have a very high growth rate and can produce a large amount of biomass in a relatively short period of time. Unlike traditional crops, algae do not compete with food production or agricultural land. In addition, algae can capture carbon dioxide during growth, which helps reduce greenhouse gas emissions. Because of these advantages, algae are increasingly studied as a sustainable bioenergy resource. Overall biofuel production process. This slide illustrates the general process of producing biofuel from algal biomass. First, algae are cultivated and harvested to obtain the biomass. Next, the biomass undergoes pretreatment to break down its structural components. After that, enzymatic hydrolysis converts complex polysaccharides into simple sugars. Finally, these sugars are fermented by microorganisms to produce biofuels. Pretreatment is a crucial step because it improves the accessibility of the biomass for enzymatic hydrolysis. Different pretreatment methods can be used, including physical, chemical, and physical-chemicals approaches. These processes have disrupted the biomass structure and increased the efficiency of sugar release. Recently, deep eutectic solvents are attracted attention because they can effectively break down the biomass structure while being more environmentally friendly. Next slide is enzymatic hydrolysis and fermentation. During the enzymatic hydrolysis, specific enzymes break down the polysaccharides such as cellulose into simple sugars like glucose. These sugars then serve as the substrates for microorganisms during the fermentation. Through microbial metabolism, these sugars can be converted into different types of biofuel, including bioethanol, biogas, and biooil. This biological conversion process plays a key role in transforming biomass into renewable energy.
So next part is about the role of artificial intelligence. The artificial intelligence is increasingly being applied in biofuels research and productions. AI can also analyze the large and complex datasets generated during the bioprocesses. Using the predictive models, AI can help determine optimal operating conditions such as temperatures, pH, or nutrient concentrations. The improve production efficiency while reducing the operational costs. On this slide, I introduce artificial neural networks, are also called ANN, are the machine learning models inspired by the human brain with the input, hidden, and output layers. They take in the data like sensors and stimulation data, process it, and also predict the outcomes such as the future state of our systems. And in the bioenergy, ANN is used for process optimizations, fermentation reductions, biomass categorizations, and biofuel yield estimations. So their main advantage is for the modeling complex nonlinear relationship, which can have improved the efficiency and control in biofuel production. Besides the biological processes, AI can also be applied to thermochemical conversion technologies. AI is applied in key areas such as gasification modeling, combustion optimizations, and predicting product use. These processes are complex and involve many variables, so AI have improved accuracies and also AI can control these. AI also enhance the overall system efficiency by optimizing the operating conditions and reducing the energy loss. Also, you can see these diagrams shows the different thermochemical pathways, including the pyrolysis, the gasifications, and combustion, and this is how they produce the output like bio-oils, sick gas, and heat. Overall, AI can help to improve the performance and also the efficiency of bioenergy systems. Life cycles assessments, are also called the LCA, is a method used to evaluate the environmental impact of a product or process. It's focused on emissions, resource efficiency, and comparing energy technologies to assess the sustainability. So the figure shows three main stages: design, process, and productions. Each stage includes activities like material design, process optimizations, and quality controls, which all contribute to the overall environmental impact. So the LCAs look at the entire system to support more sustainable decisions. Next is about the stage of the life cycle assessments. So the LCA framework typically consists of four main stages. The first stage is defining the goals and scope of the studies. The second stage involves collecting data on resource use and environmental emissions, known as the life cycle inventory. The third stage is the life cycle impact assessment, where the environment impact are evaluated. Finally, the results are interpreted to support decision making and also the improved system design. The next slide is about the comparisons of the advantage and the limitations. So about the advantage of Elgar biorefineries is Elgar biorefineries offers several important advantages, such as they can provide a renewable and sustainable energy source. They also can reduce the carbon dioxide emissions by capturing carbon dioxide during the algal growth. So, and in addition, biorefineries support the circular bioeconomy by converting the biomass into multiple valuable products. And so These benefits can make the Elgar biorefineries a promising technology for future energy systems. On the other hand, despite these advantages, several challenges still remain. One of the major limitations is about the relatively high cost of biomass cultivations and processing. The retreatment technologies can also be complex and energy intensive. So, in addition, scale up from laboratory experiment to industrial productions can remain a significant challenges and can cost a lot of money. Future research should focus on improving the retreatment technologies and developing more efficient enzymes for biomass conversion. Integrations with existing industrial infrastructure will also can be more important for the commercializations and for the future furthermore, artificial intelligence may play a key role in developing smart and automated biorefineries that can optimize production processes in real life. In conclusion, the Elgar biorefineries represent a promising stage for more sustainable biofuel productions, and also AI can significantly improve process optimizations and production efficiencies. And the life cycle assessment is also essential to ensure that these technologies remain environmentally sustainable. However, continued research and technological development are still in need and to overcome the economic and technical challenges for the large-scale commercialization. So this is our reference. This is from the paper of the Boussoulourous. The paper is called the Advancing Biofuel Production through Elgar Biorefineries, Optimization of Polysaccharide Utilizations, AI-driven innovations, and sustainability assessment from biomass and bioenergies. Thank you for your attention.